Hello students, and welcome to another how-to video on writing chemical equations. Today we're going to be focusing on double replacement reactions, okay? And we have two problems that we're going to work together. This first problem is a little more difficult than the second, so bear with me as we work through this problem, okay? This first sample, we have sulfuric acid reacting with sodium cyanide, and it's going to create hydrogen cyanide and sodium sulfate. Okay, I just said a bunch of stuff there that you probably aren't too familiar with, but what you need to recognize, okay, is that we have givers and takers in this problem. Okay, H2, okay, it likes to give electrons. Sulfate likes to take electrons. Okay, it has two parts. Do you notice how SO4? These are nonmetals, and nonmetals typically form covalent bonds and they take electrons, while hydrogen's a giver. If we notice, sodium is on the left side of the table. It's a metal, okay? And we have C and N, and those are nonmetals, okay? And they're forming a polyatomic ion as well as SO4 is sulfate and cyanide. They're two types of polyatomic ions. And it doesn't really matter too much about their properties or what their names are. All I do is want you to recognize that nonmetals, okay, if they're in groups of more than one or more than by themselves of just one element, and they're in pairs or in bigger groups, such as sulfur and four oxygens, okay, they are going to be the takers in this game, okay? So we have basically this atom is split in two. So we have our positive ions and our negative ions that we're going to form, because hydrogen's going to give electrons, sodium's going to give electrons. Now, when we write these out, what we're doing is we're going to switch places with each other. And if you notice, the H is now with the cyanide and the sodium is now with the sulfate, okay? So that's what we did in this problem, is we just switched the positive ions in this problem. Okay, now, as far as just balancing it, okay, this is all we're gonna focus on in this video. But I gave you a little overview of kind of breaking down what these chemicals are, okay? And we'll go in more depth on this. We have a whole section dedicated to this. I'm gonna have a video on that. All right, so if we look at this problem, we have H2, and if we look on this side, we only have one H, so our H's are off. We have an S and an S, we have an O4 and an O4, because you see how they're kind of like, these stick together. They don't like to break from each other, and same with the CNs. Okay, the cyanides do not break from each other, so they're gonna be the same, but our Na is different on both sides. So our sodiums and hydrogens are different. So let's start with the sodiums. So we have two over here, and we're gonna have a two over here. All right, and then we see that we now have two cyanides, so let's add another cyanide to this side. And then, oh, that just kind of solves our H problem. So now we have two H's, SO4 and then SO4. We have two sodiums, and now we have two sodiums, and we have two cyanides and two cyanides, all right? So that equation now balances out. All we had to do was just add twos, coefficients to the sodium cyanide and the hydrogen cyanide, okay? And don't let these big words scare you, okay? They're just polyatomic ions, okay? This SO4, okay, it has a -2 charge. It kind of acts like oxygen, because we know oxygen has to get the octet rule, it needs to get 2 more electrons to be satisfied. So is sulfate. Sulfate's just a polyatomic. It's acting the same way. It's just in a group. It's called a poly. Poly meaning many, referring to atoms, okay? So just keep that in mind. Okay, we've talked about those earlier in the year, but now we're going to really need to use them, and you're going to become more familiar with them. Okay, now the next problem is a little easier. It's sodium hydroxide and hydrochloric acid react to form sodium chloride in water. So let's write this out. We have NaOH. And this is going to be in a solution, so it's going to be aqueous. Okay, most of these, almost all of these double replacement reactions will be in aqueous solutions. We have an aqueous solution of sodium hydroxide, and we have hydrochloric acid, which is also aqueous. Okay, we have these two clear substances. We're going to pour them together, and we're going to see what's going to react. Okay, and react to form sodium chloride in water, so it's going to be NaCl and H2O, okay? If you notice the H and the Na, going out of focus there, we have the Na and the H, they're going to switch places with each other. Right, they're going to switch. Now we have sodium chloride and water. And NaCl is going to remain in solution and be aqueous. And H2O is now going to basically add water to the solution because water is already the solvent. So we're just going to make that a liquid. And if we look here, it's basically already balanced for us. Na, Na, Cl, Cl, H2, H, H, and one oxygen and one oxygen. So we don't need to add any coefficients. Okay, all we had to really do is just write out the equation. Okay, I think that's it for the video. Thanks for watching.